welcome to our webinar. We're very pleased to have you here today. My name is Anne-Kathrin Lindner. I'm the NGS Product Specialist for Cleaner Sciences, and we're very happy to share this webinar today with Watchmaker Genomics. And the Senior Product Manager, Jennifer Pavlika, is going to be with us today as well. And we're happy to introduce you to the new portfolio for the NGS products in our product line. So we as Cleaner Science are happy to have Watchmaker on board, and we'll be doing their distribution in Portugal, Spain, UK and Ireland, France, Switzerland and Austria. Today I'm going to give a short introduction into the company and its unique setup, and we'll be talking about the two products that are currently available, which is a DNA library preparation kit, as well as the Equinox amplification kit. And later then, Jen Pavlika will be available for you to answer your questions on the company, as well as on the library amplification kit and the library preparation kit. So as an introduction, in recent decades, we've all borne witness to the unprecedented advances in genomics technology and have seen academic, industrial, and clinical genomics markers evolve alongside. At the same time, while costs are decreasing, but the throughput and resolution is increasing, sequencers are becoming or moving forward to becoming the universal readout for biological information. Sequencing is now being applied not only for genomes and transcriptomes, but in general to the understanding of the dynamic epigenetic landscapes in various samples. So with so many important biological signals converging on sequencing, an industry mission becomes even more present. The goal for Watchmaker is to make the data recovered from the instrument to be a most perfect representation of the information actually carried within the sample. So how is Watchmaker addressing this question? Capturing a sample sequence information requires an enzymatic manipulation at multiple points from purification of the sample to preparation on the flow cell. As a result, the data quality can only be as good as the enzymatic reagents used to actually process these samples. High quality reagents are necessary for the development of highly sensitive, specific, and robust sequencing-based assays. Summarized, if you control the enzymes, you control the information. So Watchmaker here is quite uniquely situated to address these needs due to its three core competencies. Watchmaker's protein engineering developmental platform combines in silico design, directed evolution, and machine learning to interrogate the sequencing space. While at the same time, the expertise in computational biology facilitates the analysis of sophisticated NGS-based characterization datasets to disentangle the molecular mechanisms of the enzymes they are actually engineering. And finally, their strong expertise in high purity protein production, both for prototyping and a vast upscale, allows them to improve the production of the enzymes. Overall, Watchmaker is a vertically integrated company, which allows them in one house under one room to control enzyme engineering, the development of the NGS application, a full control of every aspect of the workflow, for example, enzymes, buffer design, etc., an improved supply chain consistency, and this altogether allows them to be also competitive in pricing on this very interesting market. First of all, I want to introduce you to the library preparation kit. The library preparation kit that we currently offer includes enzymatic fragmentation. Applications here, for example, can include, but are not limited to, somatic mutation calling, whole genome sequencing with or without PCR included, whole exome sequencing, metagenomics, viral genome sequencing, etc. So what is the current situation for genome sequencing? Sonication has emerged in the last years as the gold standard for an unbiased and robust DNA fragmentation. But on the downside, this requires a large-scale upfront investment into equipment, costly consumables, and it is not necessarily easily scalable to large sample numbers and automation. Generating libraries from low inputs with this method is also especially difficult due to sample loss inherent to processing. DNA library preparation chemistries based on enzymatic fragmentation on the other side are an attractive alternative that alleviate the monetary barrier to enter the bottleneck of sequencing sample processing and automatability. However, existing enzymatic fragmentation-based chemistry are not without their own limitation. Particularly undesirable are increases in bias relative to sonication, which might be introduced by sequencing artifacts. So how is Watchmaker competing in this area? First of all, I want to point to a reduced sequence artifacts that are as a result from the library preparation kit. The library preparation kit is designed to reduce the sequencing artifacts, especially for sensitive applications. On the left side, you can see a reduction in chimeric reads. So true chimeric reads point to fusion and rearrangement events in the genome, whereas false chimeric reads, which can be a result or an artifact from enzymatic library preparation, make it difficult to identify these structural rearrangements. Here we are comparing sonication to 3 different enzymatic workflows: Watchmaker and 2 competitors. You can see while Watchmaker is still not performing as ideal as sonication, there is a vast improvement compared to the competitors. And this enables the Watchmaker libraries to be better in the identification of structural variants and fusion events. Similar, on the right side, you can see a comparison with regards to hairpin artifacts. Here again, compared to sonication, there's still a bit more of these artifacts in the libraries, but is vastly improved when compared to the competitors for enzymatic fragmentation workflow. A reduction in hairpin artifacts improves again the assay sensitivity, for example, with regards to single nucleotide variants. While these improvements in the data are strong and highly desirable, on the other side, Watchmaker focused to also improve the workflow. The Watchmaker workflow incorporates an integrated fragmentation and end repair A-tailing step, followed by a same tube high efficiency ligation reaction. Overall, the library prep time is about 130 minutes. The first reaction is powered by a ligation master mix built to improve liquid handling and ease of automation. The PCR-free workflow can be finished in 1.5 hours of reaction time, while PCR-based workflows require an additional 45 minutes with an added spray bead cleanup. Watchmaker DNA library preparation kit supports inputs from 500 nanograms to less than 1 nanogram. And this is another benefit of these kits. So Watchmaker chemistry offers the workflow improvements I discussed, but not at the expense of highly desirable characteristics like a tunable insert size. So a lack of tunable and reproductive fragmentation has been a pain point for many users of enzymatic fragmentation. So shown here on the left side, there are traces of libraries prepared only with different times of fragmentation. So within this panel, it is shown that not only the insert size is tunable from greater than 500 base pair to less than 200 base pair, fragmentation is also very consistent between duplicate reactions. Furthermore, on the right side, it is shown how robust the reaction is. So you can see this has libraries with an input ranging from 0.1 nanogram to 500 nanograms, but the fragmentation is consistent across a wide range of input amounts. The panel on the right side shows an overlay of these traces and shows the reproducibility of the fragment size independent of the input amount. A final thing I want to point out is the ability of these kits to handle difficult samples. So difficult samples comprise samples such as FFPE, which are notoriously difficult due to previous DNA damage. In comparison between Watchmaker and 2 of its competitors, you can see that the yield is strongly improved, but not only for quality DNA, but even for moderately or severely damaged DNA, you can see that the yield outperforms its competitors for those difficult samples. So to summarize these ideas, between sonication and enzymatic fragmentation, Watchmaker offers very unique solutions. It allows for library preparation with only minimal sequencing artifacts, while at the same time allowing for a protocol that is much more independent on the input amount, which is scalable with a very simplified workflow, feasible for automation, and only minimally sensitive to template damage. The second product I want to talk to you about today is the Equinox Library Amplification Kit. This kit can be purchased in tandem with the library preparation kit, but also individually. Further applications include, for example, rare variant detection, cell-free DNA analysis, single-cell application, hybridization capture workflows, or different epigenetic workflows such as ATAC-seq or ChIP-seq. The idea here is to produce a highly efficient and low-bias DNA amplification. The enzyme modified in this kit has been a polymerase. The Equinox polymerase contains a proprietary proofreading polymerase optimized for ultra-high fidelity amplification. The key benefit is an overall reduction of about 40% in error rate when compared, for example, to the Kappa Hi-Fi Hot Start Ready Mix. Here it points out to 6 different errors that occur on a regular basis. And significantly, the reduction of the CT substitution is particularly important, as this mutation is associated with spontaneous deamination of methylated cytosines to uracil, but is also one of the most common mutations in cancers. So again, this decrease in the error rate allows for a more detailed and correct analysis of the samples. Beyond this error rate reduction, the yield, of course, needs to be sufficient. And for the Equinox kit, this shows that even here it performs competitively or outperforms the competition. And the Equinox library amplification kits delivers high efficiency amplification, making it possible to limit amplification bias and reduction of amplification cycles. Amplification efficiency remains robust when targeting yields greater than 1,000 nanograms. Furthermore, not only the overall yield of these amplification mixes is important, but also the uniformity of coverage is important. Fidelity problems in library amplification can sometimes be mitigated through UMI methodologies and error correction algorithms. Biases in amplification lead to an uneven representation of the UMIs. Overall, the Equinox library amplification kit enables for a uniform amplification across UMI families, supporting a coverage of more than 75% in all families and more than 90% in families with a GC content between 25 and 75%, with only a 3-fold sequencing depth. And lastly, another improvement has been made for the hot start formulation. The hot start formulation is important when it comes to the automation. Generally, with a focus on automation, I'd like to highlight the workflow improvement for Equinox. In comparison to competitors, Watchmaker has a more efficient inhibition of the polymerase and the exonuclease activity. This means at room temperature setup of such automation handlers, the reaction is protected and the samples and primers are protected from degradation or non-specific amplification, which again improves the latest sequencing output. So to summarize, Watchmaker aims to set up a new standard for NGS library amplification. Both the library preparation kit and the amplification kit together facilitate a high fidelity amplification that reduces miscooperation events by up to 40%. Also, a reduction in overall error rates and facilitates a robust error correction, which enables a better detection of rare mutations. Beyond that, efficient library amplification from a wide range of inputs, ranging from 100 picogram to 500 nanograms, and a wide range of GC contents. Additionally, effective hot start formulation inhibits both polymerase and exonuclease activity, which is important for automation and liquid handling. And overall, a high uniformity of the sequencing coverage optimizes the sequencing economy. Thank you for listening to this introduction. I would now like to introduce Jennifer Pavlika, who is a senior product manager with Watchmaker. We're gladly awaiting your questions on these products. Hi, Jennifer, can you hear me?
I can hear you just fine. I was waiting for a question. I'm here though.
So thanks a lot, Anne-Catherine, for the presentation. If you have any question, don't hesitate. It's the moment to ask your question. No question?
Very quiet today.
Yeah. You can ask your question on the chat if you prefer to ask on the chat. There is no problem. I will read the question. Oh, we have a question in the chat. Can I know what is the cost of the kits? So for this question, I asked you to contact us. You can contact us at info@clinisciences.com or the email address of the subsidiary in your country, and we will send you a quote with the price of the kits. I will wait for some other question on the chat before to finish the session. I think that Anne-Catherine, your presentation was very clear. Have you tested any volume reduction on the kits?
Yeah, that's a great question. We haven't done any direct internal testing, although, in terms of how we would anticipate this kit to perform, I mean, there's similarities to other DNA prep workflows in terms of the volumes that are accommodated and used, but we haven't done the direct testing ourselves.
So I've only introduced now the DNA library preparation kits. I don't know, Jennifer, if you can elaborate a little bit more to the future kits that are coming soon.
Yeah, absolutely. So we are really excited about some of the work that we're doing in the RNA library prep development space. So we have 2 kits that will be launching towards the end of the summer, early fall. They are whole transcript. It's a whole transcriptome RNA library prep kit. It uses a depletion methodology to remove ribosomal and globin RNA. So it's the alternative to an mRNA capture type workflow. It gives you all of the long non-coding information. It's appropriate for FFPE samples that are damaged where maybe you can't do mRNA enrichment on them. We've spent a lot of time optimizing this kit specifically for very low input amounts and very highly degraded material. So we're seeing, big performance gains in gene detection sensitivity with low input amounts, sub 10 nanogram total input and with degraded material. But we've also spent a lot of time optimizing the workflow. So in addition to performance benefits, we're also able to streamline the overall workflow and reduce the total turnaround time by about 1.5 hours to 2 hours or more, depending on what you're currently using. Makes it much more user-friendly, much more automatable, fewer consumables, fewer bead cleanups if you hate those. It makes it a much easier to execute workflow. So it's something we're really excited about.
Thank you, sounds great.
No problem.
And this will be available by the end of the year, basically.
Oh yeah, but well before that, we're looking at launching end of summer, early fall, I would say. Yeah.
Great.
And I guess actually one more product to touch on. So, we've covered today the enzymatic fragmentation DNA library prep workflow. Another one that we're excited about that we're developing is it's basically a DNA library prep solution without the enzymatic fragmentation. So for folks who are using cell-free DNA where you don't need to fragment, folks who are doing methyl-seq, so methylation type workflows, this would be a good solution for them. Or if you're just, you love mechanical fragmentation and you don't want to switch to something enzymatic, this can be, it bolts downstream of something like a Covaris or a mechanical fragmentation. So that's another one where it should be this year, this fall, at least I would say, but it's another one that we're working on that we're very excited about.
And is there also an improvement in the workflow?
The workflow I would say is so DNA on the DNA side, it's everything is very streamlined. So there's only so many improvements you can make at this point. But I would say it's minimally comparable workflow wise, and there are some advantages depending on what you're currently using. So for example, there's no user cleavage step if you're using like an NEB type workflow. So there are some small workflow benefits, but it's not there's no overhauling, I would say, in terms of the workflow.
Okay, so if there is no other question, don't hesitate to contact us if you need any other information. Our tech support will be able to give you all the answers that you need. And this webinar will be was recorded and will be available on our website in the following days. I will send you the link to the video in order to have a look or to share with your colleagues. So thanks a lot, Anne-Catherine and Jennifer for the presentation and the answer to the questions. And thanks a lot, all of you, to attend this webinar. Have a nice afternoon. Bye-bye.
Thank you, Florence, for organizing this.
Thank you.
You're welcome. Bye-bye.